Welcome to the CS235 Solidworks tutorial. This is the second round on Friday afternoon. Today we're going to be learning about how to make basic parts, and then next week, just because we didn't get quite as far as I had hoped last night, we're going to be doing assemblies and drawings, but those go pretty fast. So, the first thing we're going to do, we'll use the starter CAD for the second thing. The first thing we're going to do is we're just going to make a part from scratch. So, let me pull it up here. Everybody see on my screen? You're going to go New, and now we have three options. We have Part, Assembly, and Drawing. So part is the most basic SolidWorks thing. It's a screw, or a bearing, or a nut. It's just one part. An assembly is several parts, so maybe it's a shaft in a bearing, maybe it's a screw in a plate. A drawing is basically a black and white sketch. It's an actual drawing of it, and that's the type of thing that we send to the laser cutter or we send to a machine shop. Today we're just going to be doing parts, so hit OK. And now everybody's screen, hopefully, did that work for everybody? Not yet? Okay.
Also, the bottom of yours looks cut out just a little bit.
Oh. I don't. Yeah. Okay. So on the left-hand side of my screen, I'm going to show you. So this area right here, this is where you'll see all of the features of SolidWorks that we're making. So I'll explain what those are later, but just real quick, you know, everybody knows what XYZ Cartesian coordinates are, and that's what we're using here in SolidWorks. So this is our origin, that's 0, 0, 0. And then these are our orthonormal planes. These are our principal axes. And there are two types of main things in SolidWorks. So just to show you, you've got buttons up here that do things. And all of these buttons can be found also in drop-down menus. So you go to SolidWorks and see all of these menus. These have all the same buttons, just as text. So the two main type of operations in SolidWorks are the two main type of operations just in the physical world, which is adding material and taking away material. So say we wanted to make, I don't know, a human head. Maybe we'll start with a sphere. So that's adding material, and then we'll carve away some holes for the nose and carve away the eyes, so that's taking away material. The reason this is that SolidWorks is just a way on a computer of representing real-world physical stuff. So it has to make physical sense even in SolidWorks. So the first thing we're going to do is we're just going to add material. So go ahead, everyone select front plane. Now you see how it turns blue? That means in SolidWorks, typically, when you've selected something, it turns blue. Now hit this button here, Extruded Boss Base. So an extruded boss base is basically, in SolidWorks, the most basic things, extrudes. Basically, they take a two-dimensional sketch, like a circle, and then they stretch it in the third dimension. So, you know, imagine like a Twizzler. Oh no, that's a helix. That's bad. So basically, you know, like an aluminum tube. So you start out with a two-dimensional ring, and then you just pull it. So we're going to do that. So everybody select the circle, and watch on my screen for a sec. SolidWorks does a lot of so-called smart features, where it tries to auto-align you with other things on the screen. So right now, it's trying to say, would you like to align with the axes or the origin? We're going to align with the origin. See how it turns red on my screen? So go ahead and click once. And now you see that we can drag this circle to make it whatever size we want. So it doesn't matter what size we are right now, just go ahead and click somewhere. Now, our icon has a little circle on it. See your mouse? That means we're still in circle drawing mode. So to get out of that, you hit Escape. Half of the errors that happen in SolidWorks are because we're still in the mode of the thing we did last, and we don't want to be. We want to do something else. So say I want to draw that circle, and then I want to draw a square, and I keep drawing circles accidentally. That's why. Now everybody hit escape like 20 times in a row. And you'll notice nothing's happening. Nothing's smoking, nothing's exploding. You will never get in trouble in SolidWorks by hitting escape. It's completely safe, so just anytime you're having an issue, just try hitting escape and see if it fixes it. So now this button right here, Smart Dimension, this we'll be using a lot. This is how we give things size. So press that, and now click on the circle. Now before you click, you'll notice, see as I pass over the circle it turns red? That means that if I click, I'll select the circle. And that helps you when you have a lot of different things you could click on. You wait until it turns red before you click. Okay, so now I've got this diameter. Click somewhere else on the screen, and it asks you to enter a number. So this is just the diameter of it. And we're going to do 82.5026. So 82.5026. Okay? And now hit escape, so we're out of that mode. Everyone's circle should be black at this point. Is everybody's circle black? Okay. Now I want you... Don't tell me my keyboard isn't working. Okay. I want you to select that dimension and hit delete. Now what color is your circle? Blue. In SolidWorks sketches, black means fully constrained and blue means under constrained. You don't want to be using, in the end, your part, all the sketches should be black. And we'll go over why that is later, but basically things can change if they're not fully constrained, and maybe it'll only be a very slight change that you won't notice, but it'll be enough to screw up your robot. So go ahead and hit Control-Z. Control-Z does, in fact, undo things in SolidWorks. Okay, now take a second circle. Put it in the center and make it a little bit bigger than the last circle. Now Smart Dimension that to 98 millimeters. By the way, everyone's in millimeters, right? You should be a millimeter gram second. Everything we do in the class will be MGS. Does everybody's screen look like mine? Huh? 98 millimeters. If you're falling behind, let me know. Or if I'm going too fast, let me know. The goal is for everybody to have these parts to use by the end. Okay, so now we've made circles, we're going to make lines. I'm going to draw two lines, and you guys tell me what the difference is. What's the difference?
One's construction?
Yep. So this dashed one here is a construction or reference line. That means SolidWorks won't interpret that as a line in a solid object. It's just kind of like a light sketch that helps me, you know, as the SolidWorks artist, constrain things. And this solid line, it will try to build that as the edge of something. So this line here we use to align things, but it doesn't get built. This one is an actual line that will get built. So I want you to take and you see here on this line button, there's a little arrow. That little arrow lets us access all of the types of lines. So go ahead and take a dashed line and put it one end in the center and click, and don't click again. And let's play with this line for a sec. See how I can drag this around? So SolidWorks is going to do a couple things. If I go vertically, it tries to snap me to it. You see how when I snap, a little yellow and black vertical line appears? And now if I go down horizontal, a little horizontal line appears. And now if I go at a 45-degree angle, it tries to snap to that. This is SolidWorks trying to be smart. It will snap to 0, 90, or 45 increments. So for now, I just want to do a vertical line, and I want you to put the end of that line, look at my screen, right in between those two circles, right here. Okay? And then hit escape. Does everybody have that line? Okay, now, this is pretty hard for me to see. Look at my screen. If I were to try to do anything to that, I'd screw it up. I just can't see. So now, does everyone have an external 3-button mouse? No? Okay. So that's absolutely critical. And Um,
I mean, I'm okay for this.
I'm not sure. Have you ever used Solidworks before?
No, but I'm pretty good with Pro 8.
Okay, well. So everybody take your scroll wheel and kind of zoom back and forth. In SolidWorks, this is what scrolls back and forth. Okay? So now anytime you can't see well, just zoom in, because otherwise you'll select the wrong thing. So take another circle and center it on the end of this line. See how it snaps to that line? And it doesn't matter, just make it big enough so it doesn't touch either of the circles. And now take the Smart Dimension tool and give it a dimension of 3.2 millimeters. Now, is that hole fully defined? And how do you know it's not?
Still blue.
It's still blue. So let's give that a radial length. So click on the dashed line and give that line a length of 45, and it turns black. It's fully constrained. Okay? Now we're going to do a second line. So go to the line, drag a center line, put one end in the center, and put the other around 30 degrees on that same radius. See here?
Sorry, my line is black.
So, okay, if you select the wrong line, that's okay. In fact, I will delete that and do it. So everybody watch me for a sec. So I selected the wrong line, and that line is solid. Is this what you mean?
Yeah.
Okay. It's okay. Click on the line, and then do the little, on the left, you hit for construction, and it's converted. So anytime you draw a solid instead of a dash, or a dash instead of a solid, you can always use the for construction to change that. So now take a circle and put it at the end of that line, and then dimension that circle to 2.6. Everybody got that? What's wrong, David?
Guess I'm a step behind you.
It's okay. So go ahead and draw the construction line.
Oh, okay. That one, what particular angle is that one at?
It's arbitrary at this point. We'll dimension it later. Okay, so let's go ahead and set that line. Interesting. It's crazy. Also, everyone should buy a mouse pad, because my mouse is like doing crazy stuff of its own accord right now. So Smart Dimension. Now click the line, but don't click again. Let's play with this for a sec. You see how right now it's in the right direction on my screen? This is a radial dimension. Now up here it's a horizontal dimension, and then over here it's vertical. So SolidWorks allows us to do basically whatever direction we want. Just so you know, if you're trying to go along in the direction of the line and you can't, you just need to wiggle your mouse until you go to a position where it can. So make that 45 in length. And now I want everyone to zoom out to about here on my screen. And we're going to see the second most common error in SolidWorks. What was the first? Escape. Okay, now I want to select the angle between these two lines. So I'm just going to show you how you do it first. So you take the Smart Dimension and click on the vertical line. Then you click on the second line. Now you see this angle? I click in between, and I can set it to whatever I want. And I'm going to say 45 degrees. And it turns black. It's fully defined. Awesome. Everybody got that? Now I want you to hit Control-Z. Oh, and Control-Z again. Basically, just get back to where you don't have an angle. Okay, now zoom way out. And we're going to do the same thing. So Smart Dimension, and try to click. And you will notice you can't. You see how it's highlighting weird stuff? For me, it keeps highlighting, see on my screen, it keeps highlighting the 45 instead of the line. And now it's highlighting these weird things. Basically, SolidWorks thinks you want to click on whatever is nearest to your mouse cursor. If you're zoomed way out, so that your image is super small. It doesn't have sufficient resolution to select the proper thing. So if you're zoomed out like this, it will keep selecting the wrong thing and your sketch will get screwed up. There's no reason to work with small. Always zoom way in whenever you can. So let's select those two lines, angle in between, 45. So now the two common mistakes we've learned are escape and to zoom in. You don't want to work too zoomed out. For one thing, it'll strain your eyes. Okay, does everybody's sketch look like mine? You're really good without a mouse. I'm impressed.
Little slide.
Yes.
Okay.
So I was going to ask, you were panning around before.
Uh-huh.
How do you pan?
We're going to go over that in a sec. So I want, basically I'm going to pattern these all the way around here, but I'm lazy. I could just draw a whole bunch of lines, but later on, you know, in next lab we'll be doing stuff like 100 teeth on a belt pulley. That'll be a lot of lines. So instead we're going to do an angular pattern. So what I want you to do, man, this mouse is crazy. I want you to zoom in, select one circle, then hold down the control key and select the second circle. You can't select more than one item in SolidWorks without holding down the control key. You should have two little blue circles now. Now go to this SolidWorks icon, kind of hover above, and do Tools, Sketch Tools, Circular Pattern. You see that? Everybody got that? So it's Tools, Sketch Tools, Circular Pattern. And click that. Now look, you see the little yellow circles that appeared on my screen? That's just a preview of where it would like to put them. So SolidWorks, one of the main things you need to know about SolidWorks is that it's really complicated. It has many widgets and bells and whistles that you can use and very complicated functions. You don't want to use any of them. I will tell you the bare necessity ones you want to use, and that's all you want to use, like Legos. They're just a couple parts and you repeat them a billion times. Otherwise, you're going to screw yourselves because they're sort of black box functions, they're buggy. People who actually work, you know, as professional designers sort of pride themselves on being gurus of SolidWorks. Like if you were to go to Lockheed Martin, they'll probably make fun of you if you don't know about the most cutting edge macro. But that's lame, and they don't work, and I've been bitten repeatedly by them. So on the left-hand side, you'll see all of these different things you can do. We're not using more than one of them. All I want you to do is everybody in this little menu. Make sure equally spaced is checked. And then I want you to set the number first to 2. Press enter. You see how we only have two sets of holes? Now hit it to 3 and press enter. We've got 3. And we're actually going to end up with 4. So make sure the number 4 and then hit the green check mark. Note that enter does not do anything. In SolidWorks, in the sketch, you have to press the green check mark to have it take commands. Everybody tried just pressing enter? Oh, hey, it did it. Alright, never mind. Oops. Okay, everybody's screen look like this? So, what's wrong with this picture? Blue. I don't understand why this is. If anyone can figure it out, I'd be eternally grateful. For now, so click on one of these little blue holes in the center and drag it around. Now notice this is no longer the angular pattern we once thought it was. This is why you never want to leave things blue in your sketch. Okay? Hit Control Z. So the way we fix this, at least the way that I fix this, take a circle, put it in the center, now drag up to the top black hole, and let it auto-align with the center of that hole. See? Look at my screen for a sec. And then click. Now on the left-hand side, click the check mark for construction, and hit escape. Everybody got that? Now zoom into this little blue hole and select the center, hold control, and select that dashed circle we just made. So you should have both. Now look at my screen. On the left-hand side, we've got a couple options. See this bottom one, fix? Do not press it. Never press it. Never in this class or in your career will you ever be okay to press fix. What fix does is it freezes the SolidWorks model for all eternity until we press that button again. And it sort of allows certain things to happen in SolidWorks that don't make physical sense. It sort of suspends reality while that button is pressed. So if you have an assembly of parts and some of them are fixed and some aren't, it will do weird things, and then one day you'll unpress fix and everything will explode and you'll have no recollection of how things should have been. So never press that button. Concentric would make them concentric. We're not doing that. We want to press coincident. And actually, my thing just... It's so annoying. My mouse is not being cooperative, just so you all know. Okay, so press the center of the circle, control the big circle, and hit coincident. It's center of the circle. Now, it's still blue. That's because we need, basically, for an angular pattern, we need to take two of those patterned things to do it. So now select another blue circle you didn't do. Select the center, control the big dashed circle, and hit coincident. And now you'll note they all turned black. Okay? Now, go back to that circle we dragged before, select it again, and try to drag it. Doesn't drag. It's black, it's constrained. SolidWorks doesn't let us drag around or change constrained stuff. So we're good. Everybody where I am? Okay. If you have a problem, I can help you. It's okay.
I accidentally pressed the button and it extruded.
Oh, good. You're on the next step already.
Accidental.
Okay, so there are two buttons that Hannah's beat us to. It's Hannah, right?
Yeah.
Okay. Dude. Okay. See this button? Don't press this button unless you're willing to discard all of the changes in our sketch. That's the I didn't press the button. That's the emergency button. You don't want to press that unless it's an emergency. This blue-purple button is the good button. That means we're happy, we're going to go ahead and extrude. Press that button. Awesome. That's cool. And it should look like... Give me a sec. Does anyone have a mouse pad with them?
I have a notebook that you could just...
Would you mind? This is killing me. Thanks.
Yep.
Okay, so basically my mouse is sort of making life very difficult, so I'm going to go ahead and apparently it was clicking things while I was not paying attention. Okay, so does anyone know why I was receiving an error? Because basically what had happened was my mouse clicked to do that pattern twice. So anytime in SolidWorks that you do something that doesn't make physical sense, such as put one circle on top of another, it will whine at you, and it should. It will tell you something like you have nested circles or you have intersecting models. Anytime you get that warning, it'll be when you press the button to go from the sketch and extrude it. That means you have an extra circle or squiggle or line somewhere, and you have to go back and fix it. So that it's good it happened to me, because that was one of our next lessons. Okay, so everyone should have something that looks like this. I want you to type into the number 50 and watch it grow. Now type in 0.1 and watch it shrink. So this is just telling us the thickness of the extrusion. In the end, I think we want 5.85. And hit check mark. Okay? Now go ahead and save. Now it's very important. Solidworks, for some reason, tries to save things in squirrely positions, like the temp files of Internet Explorer. I don't know why. Always make sure that you're saving it in the folder you think you are, because otherwise what will happen is you'll email me an assembly, but one of your parts will be somewhere random on your computer and I can't open it, but it opens perfectly fine on your computer because it knows all the random spots to put it. So how about just CS235 test? And you want to save frequently. After every major operation, save, because it will crash on you rather randomly. So now I want to show you something really cool. This is the third most common mistake. Go ahead and select boss. And you see this little plus sign next to it? Expand that plus sign. You see how it has sketch underneath it? So everything in SolidWorks, well, most things in SolidWorks are based on either a sketch or a curve and a sketch, or two sketches. And basically, this yellow thing here, boss extrude, that's called a feature. And a feature is an action performed on a sketch. So I could take the same sketch of a hole, and I could either cut that sketch into something or build it up. Different features, same sketch. Sometimes you get to the point where, for some reason, you only have a sketch. So go ahead and select boss and hit delete and hit yes. And we're left with just a sketch. Okay? Sometimes what will happen is you'll make the sketch and you'll have a slight error and you'll fix the error, but then it'll kick you out of the feature menu. So you fix your sketch and the sketch is good, but now you're like, oh shit, what happened? I can't, I'm not extruding. Just select your sketch and hit the extrude button again, and we're back where we were. So that is, you can either make an extrude starting from scratch by clicking on a plane and sketching, or from another sketch you've already made and you just select the sketch and hit extrude. Okay, now we're making this out of plywood. Does this look like plywood to anyone? So it's good in your SolidWorks models to make things look at least dissimilar enough from other parts that you can tell what's what. So let's color it. So go up to SolidWorks, Edit, Appearance, Appearance. It should look like this. Okay? Now press this brown down here. See how it changed colors? We can blue, hot pink, Porsche red, hepatitis yellow, black, white. We're going to select with brown.
You also do the wood in the...
So that's one of those like things I never use that SolidWorks offers because it screws up a lot. So we're not going to do materials. You can put in mechanical materials, but personally I never use them. And hit OK. Now go back into that menu again. Edit, Appearance,
Ruben, how do you get...
and Appearance.
Thank you.
Okay, so some of these holes are precise, some aren't. The 3.2 millimeter ones are meant to be through holes for screws. That is, the screw goes through it, it has clearance, but that's all it does. And some of these are for dowel pins. The 2.6 millimeters are press fit for dowel pins. So it's good for you to color code things so you know what's precise and you have to pay attention to and what's not. So for these 4 little holes, I want to turn them blue. So I'm going to zoom in here and I'm going to select that hole and then hit blue. Now hopefully your whole thing turned blue, right? Did everybody's whole thing turn blue? Basically when you click on that part, it always selects the entire body. And that's bad. So this is one of these little quirks I'm showing you. Do you see over here how it says CS Test 30, delete that. Now hover over each of these little buttons. Select faces, select surfaces, select bodies, select features, select part. If you only want to select one little part, first you have to say something like select face, then you click the hole, then you click the color. And now just that hole will be colored. Okay? Everybody see that? So now you should have this button here, select face. And now press your green check mark. Everybody got that? Okay, go ahead and save. Sometimes it really spazzes out after you change the appearance. It crashes a lot during that process. So now we've got a cool three-dimensional part. Let's play with how we control it. Everybody zoom in and out. You know how to do that with the scroll. Now, instead of scrolling, just hold that scroll wheel down and move your mouse. This is how we rotate objects. Now, hold that button down and the control key, and that translates it around. And that's all you ever need to do, just in terms of with your mouse controlling it. So let's together zoom, rotate, translate. Can everybody do that? If you can't, it's going to be a long lecture, so let's make sure we do this. We good? Now say that, alright, everybody rotate your part to some random orientation, sort of on my screen. And now go to boss. Say we decided we don't like one of these diameters, we want to change it. So right click, you see this button here, edit sketch? That's how you go back and modify something you've already made. Now, it's kind of hard to see, right? Like your drawing you made head on and now it's rotated weirdly. So the way you get back is you see right here, this little icon gives you all of the different orthographic and isometric and normal views that you could possibly want. This button here is really important. That arrow is normal to a plane. So press that and see how your sketch now, it's easily modifiable. Everybody got that? Okay, cool. So go ahead and just hit the purple mark. Yep. Play with those buttons. Go ahead and go through each of them so you can see it rotates you to different planes and faces. Go ahead and select one of these big faces and hit the normal to button. And now hit the normal to button again. Anybody can tell me what's happening?
Showing you the other side of it.
Yeah, it's plus or minus of that normal vector. Okay, now watch my screen. Say something happened, something bad. I'm way zoomed out and my part is lost. I have no clue where it is. This will happen frequently. Like you'll just, I don't know, you'll spill your Coke or your mouse will get possessed and your part's lost. Does anyone know how to get this back?
F. I have a shortcut, just F to fit the screen.
That's very good. The other thing you can do is just isometric view right there. And we're back. And I think your fit to screen...
You can set, I think, your...
Okay.
It's default.
Yeah, default. Or I think I just... I think O is default.
Okay.
I might do it too.
Real quick, this up here on my screen, display style, this toggles the type of display. So let's go through them. This has hard black edges. This doesn't. This is wireframe. And now check this one out. This shows me all the way through the part. We'll be using that one a lot. Just so you know, if your computer's running really slowly in a big assembly, it's because you have it with black edges on. If your computer can't take it, do the second one shaded without black edges. Okay? So go ahead and save, and that's this part. And this is an actual part from the homework, which you now have done. Congratulations. So, now we're going to do the next part, which is significantly harder. Everybody, this one we're going to modify from CAD. So, do file, open, navigate to your thing, and now see right here I have like 30 different file types. Anytime you can't find a file, but you know what's in the folder, hit all files. Okay? Now I want you to open the rush gears blah blah blah.step. It's the only one that's got a blank icon. And hit open. So it's going to ask you if you want to run import diagnostics on this part. No. Do I want to proceed with feature recognition? No. These are so-called smart features of SolidWorks that actually don't do much helpful. Does anyone have a gear that looks like mine?
Which one is it? The rush gear?
Rush gears blah blah blah.step. And it's got a blank icon. And all the others will have little pictures. Everybody got one? So while everyone loads that, I'm going to tell you why we're doing it. So why didn't we just make this from scratch? Because it's a pain in the ass. I have never, ever made a gear or a pulley from scratch because the teeth are actually really complicated. They're mathematical equations. They're functions. I would always recommend that basically you go to a manufacturer's website and download the CAD, and I'll give you guys a list of that. We can do Stock Drive, WM Berg, Misumi, Rush Gears. They sell thousands of these a year. They know that they work. Just go with those. But here's the thing. I don't like this gear because I have no way of attaching it to a shaft, right? And maybe it's not the perfect size. So what I always do is I download their gear teeth, and then I modify it to whatever I need it to be. So for the lab, I've modified every single gear that you use. And I'm giving them all to you, but you all have to make one. And then the one you make, we're going to 3D print. Okay, does everyone have a gear? Everybody good? Okay, rotate your gear around like this. Select this face and hit Extruded Boss Base. Now so that we can actually sketch it, go here and do the select normal face so that it rotates to the proper view. And before we proceed, let's make sure everybody's here. Anybody having trouble? Good? Okay. Take a circle and put it right here. And then take a second circle and put it outside the gear. So you should have two blue circles and a second wide dimensions. You okay?
It's a new install, so we have to grab, stuff it, and all kinds of things just to get to the files.
Okay. Okay, does most everybody have two circles? Not yet? Okay. If anyone needs me to come take a look, I'm happy to do that. Should I go through that step again?
Yeah, can do that.
Okay. So from here, select this face and hit Extrude Boss Base. But I can't sketch like this because it doesn't look right. So press this button and then press the arrow on the plane. Okay. Now take a circle and put it in the middle, about there, and then do a second circle and make it bigger than the gear teeth. Now dimension that inner circle to be 8.1. And what happened? Does that circle look too big, too small, just right? Too big. I wanted 8.1 millimeters. I think that current hole is 12.7. So what happened? Anybody know? It's in inches. A lot of the time you download parts online, especially from US companies, it's in inches. Because for some idiotic reason, the US still uses inches. If you downloaded it from Misumi, which is a Japanese company, it would always be in millimeters. So anytime you enter a dimension and it blows up or shrinks, like ridiculously, you either need to multiply or divide by 25.4. So everybody go ahead and now add a divide 25.4. And before you hit enter, notice I'm typing an equation in here. It doesn't just accept numbers, it accepts equations too. I could even do this. I could do 4 times 2 plus 0.1 divided by 25.4 and hit enter, and it sizes properly.
I actually just typed in 8.1 mm and it worked.
Did it really?
Yeah.
Well, that's awesome. Let me try that. 25 mm. Holy crap! Thank you. That's cool. Okay, so just type in mm. You learn something every day. Okay, and now press the purple pencil thing. We're done with that. But now we have a different type of thing. Look over here. See, I have different things. Blind means from that plane.
Wait, you size the outer circle?
Yeah, to 25. Sorry.
Okay.
Size your outer circle to 25. Forgot that.
How big did you boss extrude?
Well, we're going to play with this for a second. Does everybody have a screen that looks something like mine?
What's the yellow part?
That's your extrusion. So the features and should I?
What do you select the how you do that?
You want to actually this one is
Yeah, just get rid of that. Also extrude.
Okay. So everybody doing okay? Okay. Oh God. So basically, when I get up and walk, my mouse starts vibrating. Okay, see this little yellow thing? This is the preview. So everybody hit 1. Blind means we're just going by that depth in that direction. Now look, when I press this arrow, I can reverse the direction. Or I could do through all, which means it's going to go for as far as it can. You usually only use that for cuts. I can do mid-plane. Now, instead of doing 1 inch in one direction, it splits it. It does half an inch on either side. We're actually going to do up to surface, okay? So hit up to surface, and basically it's going to extrude until we hit the surface that I pick. Zoom in right here. See this lip on my gear? And select that. Now you see how it extrudes to that surface? Has everybody got on their screen what I got on mine? Again, if you can't find the surface, just zoom in. It's really hard to click these things. And Solidworks crashes quite commonly when you do something physically impossible. So if you were, say, to click on this surface or this surface by accident because you weren't zoomed in enough, there's a good chance the Solidworks will think for about 10 minutes and then close down. That's why you always want to zoom way in. Okay, so it's this. So look at your gear. You see that lip right here? Zoom in. It's this ring. And then when you've got that, hit the green check mark. Now let's go ahead and save. Anything you turn into me, please have CS235 and then your initials and then whatever else you want. Try to make your file names self-descriptive. So for this, I would put bevel, because if you turn in file names like foo or part 1, part 2, part 3, I don't know what those are, and it makes it a lot harder for us to figure out if what you've got is correct. Now notice it converted that to an .sldprt, a SolidWorks part. That's what we want. The other ones, .step, .igis, .stl, these are universal file formats. They can be sort of a pain to deal with. So I always want SolidWorks files. Okay. Everybody got this in front of them? So now rotate your gear like this and select this face right here. And hit extrude. And then do the normal button so that we can sketch. Okay, go up to this button here and turn on the lines. See how circles appeared that we couldn't see otherwise? If you're trying to find a feature and you can't find it, the odds are that you're in the wrong display mode, so it's not shading something that should be, it's just blending in the background. So everyone's screen should look like mine before I proceed. Go.
Did you put the sketch?
On this surface right here. We're good? Okay, take a circle, put it in the center, and put it about here. So let me just tell you what we're doing real quick. Don't rotate your part, but I'll show you what we're doing. Basically, we downloaded this gear model, and it had a bore of like 12.7 millimeters or something. And or it had a bore we didn't want, so we had to change that bore. So that's why we're going through all of this, to make that bore, that central hole, the size we want. Now, we set the original bore to 8.1 millimeters. I could dimension this second hole to 8.1 millimeters. Does anyone know what the problem with doing that is? Now I have to do two operations if I decide to change it to 9 millimeters. If instead I only ever set 8.1 or 9 or X once, and then every other time I based the other on that last dimension, it's much easier to update. So here's how we're going to do that. Click on the circle, and then click on the innermost circle of the actual part, and hold Control so you can get both of them. Now in the bottom left corner, I want you to click co-radial. That means it's going to be on top of each other, the same radius. And now when you press escape, you see how the circles on top of each other and it looks black? Now we're going to do that again. Circle, put it in the same spot. Now select that circle and you see this one right here in red? That one. Co-radial, and we're good. So before we extrude, everybody should have two circles that look like mine. And if you find it hard at this point, say we had a lot more than this and we were doing gear teeth too, and you can't tell what's a black line you added and what's a black line in the model, go back up here, turn off shaded edges, and now you see the black lines stand out a lot better. Cool. So now press the purple pencil thing to go say we're done. And I want you to do up to surface, and then select this front surface here, the top one with the gear teeth. And then hit the green check mark. So everybody can see now we have a hole that goes all the way through the gear that is the 8.1 millimeters that we had wanted.
Could you just go over the last step again?
Yep. So you want me to draw the circles for you?
No, I mean okay. Which part do you select to extrude?
Which face?
Uh-huh.
That face right there.
Oh, the circular. Okay.
Everybody good? Okay. Now the next thing we're going to do, we're actually going to do a cut based on a plane. So I want you to select select the right plane. And this is the first cut we will have done. See this button right here, extruded cut? Press that. And now do the normal button. And everybody's...
Hold on one second. It's not letting me extrude that face.
Everybody should be getting their thing to that. So what's happened here is it kicked you out of the extrude. So you select the sketch and you hit that button. See? All that happened was that it kicked you out. Okay, so everybody, if you think that you have made a sketch that's good, and you see a sketch in the left-hand side of your screen, but there's no extrusion, it kicked you out for some reason. So just select your sketch, hit extrude, and it'll do it for you. Now hit extrude. Up to surface. And now select, right there. Okay, is everybody good? So everybody select the right plane, extrude cut, and now your screw. Wow. Can't believe I weigh enough. I'm shaking the floor as I walk. Okay.
Sorry, where's extrude cut?
So select right plane, extrude cuts right here. But also, if you can never... So SolidWorks will sort of change these buttons around for some reason. So let's find it the right way. SolidWorks, insert, cut, extrude. It's the same thing. Now and then, you know how like sometimes on Windows your start menu will go crazy and go to the side of the screen. It takes half an hour to get it back. It's the same thing with SolidWorks buttons. Okay, so now take a construction line, that's the dotted line, and along this right edge, you see how when I get near the middle it wants to snap to the middle? click on the middle of that line, and then drag left somewhere beyond the gear and press the other end. So now you should have a horizontal line, and on the right hand side you see this little icon here that's a dot in the middle of a line. That means it's a midpoint constraint, midline constraint. Okay? Now up here is a rectangle. There are a bunch of different rectangles. We're going to be using two today. The first is a center rectangle. Click that. Click on the horizontal line about here and drag up, and you see I want you to let it it's going to snap to the edge of the gear right here like this. Go ahead and do that and hit escape. Everybody have a rectangle? So now let's size it. Hit Smart Dimension. Make the rectangle width 1 millimeter. And then select the distance between this line here and this edge of the gear 1 millimeter.
Does it matter if it's selecting the small circle or the long circle? Like, I have an option to choose either that small surface or a large surface.
That's okay.
Maybe I can choose this short surface?
Oh,
or I can choose
the big one. But that's an excellent question. A lot of times it'll offer you different things. Make sure you're selecting the thing you think you are. Okay, does everybody have a something that looks like mine? Now I want you to do through all. And you should see that we have a cut in our gear now. Everybody have a cut in their gear?
Sorry, where was through all?
Here in this drop-down menu, instead of blind, choose through all. And again, if I go up there, I can say flip side. Whoa, don't do that. I can change the direction, so I can cut either way. Just cut up. Is everybody good with that?
No, I'm still stuck in the sketch and I don't know where the cutting through. Sorry.
Okay. Yeah, so you're good. All you have to do is press this.
When you do things like that, do you want to have an overlap in your 2D sketch? Because if you do it just at the border, you know the rectangle? At the border there might be a line where it's
Sure. Yeah.
perfectly sure if
The
you-
reason why we're okay is SolidWorks automatically snaps to. And then if we were to change that dimension, it will grow our rectangle with it.
Okay.
If we just went over it by some arbitrary amount, and then we went back and changed our gear,
Yeah.
we might change our gear by enough that then our cut doesn't work anymore.
Okay, but if you snap on it, it will know I want to cut also
Yes.
at the border
Yes.
where it snaps.
Uh-huh.
Because I know in other applications it's always a problem.
In SolidWorks, it will always cut that infinitesimal line.
And with Solidworks that thing works.
Work? Yep. Okay, does everybody have a cut? Whoa. Okay, select this face, extruded cut, and then do the normal. Okay, everybody here? Now go back to rectangle, and this time select corner rectangle. Put one corner at the center, and then drag up somewhere up here, and hit escape. Now take the smart dimension, make this something crazy like 50, and then select between the two long lines and make that 1 millimeter.
Is this extrude cut again?
Yeah. Or if you want, you can do the insert cut extrude.
1 millimeter is the width of the.
Yeah. Whenever you can, if it's something where it's just an arbitrary number, pick round numbers, because then later if something's not working, I'll show you how to measure things. If something's not a round number, then you know it's not your number. So I could make, this is just a gap. Basically what this is a clamp. We're going to use a screw to clamp onto a shaft. I could make that space whatever I want. It could be 0.939. But then if I make it 1 and it's not 1, then I know, hey, something's wrong. Also, when you measure with calipers, you don't have to go back and look at your CAD. You know if it's not a round number, it's not correct. Press the purple thing, we're done. And now I want you to, instead of blind, in this drop-down menu, select up to surface, and watch the surface right here. See this? Click that. And when you're done with that, press the green check mark. Everybody got a cut?
What kind of rectangle did you use there?
A corner rectangle.
So one corner in the center.
Yep, one corner is good. Yep, exactly. Yep, up there. Good. And then smart dimension. Excellent use of zooming. Yep. 1 millimeter. Okay, has everybody got a cut? Awesome. Go ahead and save. Okay, the next one's super easy. Everybody rotate your gear like this and select this back surface. Now, I'm just going to tell you why we're doing this now. The gear, this length here, from here to here, is too thick just for our purposes. We want to thin that. Again, this imported thing means we can't modify that. It's just the manufacturer made it a given dimension and we have to modify it. So we're going to cut the back. So go ahead and select this surface. And this time let's go through the menu. SolidWorks, Insert, Cut, Extrude. Do the normal face thing. Take a circle, put it in the center, make it bigger than the gear. I don't know, I'm going to call it 50. And then exit, and then this time we're going to do something different. In the drop down menu, do offset from surface, and see this surface here? Right here, click that, and type in 8 millimeters. So what that's doing is it's going to cut up, but it's going to leave a gap of 8 millimeters from the surface we selected.
Wait, could you go over that last bit again?
Yeah.
I have the extrude option, so now I'm just choosing.
Okay, offset from surface,
Okay.
and then select this surface right here, and then type in 8 millimeters. So this is a super helpful one, because it lets us use other geometry to define the depth. Everybody good?
Which surface are we going up to?
This one right here. We all good? Press the green check mark. So now you should have a shorter gear, right? Go ahead and save. Okay. Now, everyone's gear should look like this. This is what your gear looks like. Select this surface here and extrude cut and do the normal thing. Now I want you to switch to wireframe view so that we can see through. Actually, you know what? Don't do that. Keep it like this. Take a construction line. Wait, yeah, we do. Okay, go to wireframe view. Take a construction line and watch my screen for a sec. So basically, I want to put a circle halfway in between this line and this line. Okay? So we're going to use a midpoint constraint. So in wireframe view, you take a construction line, and you see on my screen how it turns red and it wants to make me snap to right there. Snap there, and then zoom in and snap here on the inside. Here, I'm going to do it again for you.
What's the feature we're using again?
It's just an automatic snap thing, but it's doing it in the middle. So everybody take a line, and you see how on this line it wants to auto snap me onto the line, but also in the middle. Let it do that. And then down here on this line, the innermost, it'll snap to that one too. This is sort of a tricky thing. Does everybody have that line? That one. This is one of those things where you just gotta like keep eyeballing it. Good?
Why is that one there?
Because in wireframe view we see through the entire part,
Okay.
so we're able to see everything. It's really quite confusing. Zoom in for me. Perfect. Okay, now everybody take a circle and put it in the middle of that line. See how it snaps to? And then I want you to dimension that 3.6 millimeters. Okay, press the purple check mark. And now I want you to do, in the drop down menu, do mid plane. And let's do 5 inches. Just make it big. And then hit the green check mark, and you see it cuts all the way through the entire part.
5 inches.
Yeah, just something big. Does everybody have a hole in both sides? Uh-huh. What's up?
Just arbitrary.
Everybody got a hole on both sides? Okay. So now the next part is it's a little bit different. So you see these planes here, right, top, front? We can add more planes and add more axes. It's critical for a lot of out-of-plane stuff to have additional planes and axes. The first thing we're going to do is we'd like a central axis that shows us where the shaft will go. Select right plane and top plane with the control button. Go Solidworks, Insert, Reference Geometry, Axis. And the axis will appear in yellow. See that? Click the green check mark and it persists. Okay, so this is useful for now, but if we put this in assembly, the axis shows up in the assembly. And now if we do hundreds of these, it's a mess. We'd like to keep it but not see it. So go ahead on the left hand side and click on axis, and you see this little glasses thing that says hide. Do that. And then do it again and do show. This is how you hide things without deleting them. Now we're going to make some planes. Everybody select right plane, and then go Solidworks, Insert, Reference Geometry, Plane, and do 1 inch. See how a plane pops up? Click the green check mark. Now we're going to do it again. Select right, Solidworks, Insert, Reference Geometry, Plane, but now it wants to put the exact same plane. This little button flips the side. So flip it so now we have 2 planes on either side of the gear. And do the little green check mark. Go ahead and save. The reason I'm making these planes is sometimes you have to add additional planes to make certain cuts. Does everyone have 2 planes? Okay. If you don't, let me know, because we can't do the other things until we get them. Okay, so I want to select this plane up here, and then do insert cut, and then do the normal so we can actually view it. Okay?
What's the insert cut?
Extruder cut. Extrude.
Yeah, sorry, insert cut extrude. Everybody should look like this. Okay? No? Is yours reversed? Press normal again. Alright.
Plane to the right of your part if you're looking at the back.
Take a circle, and you see how I can snap to that other circle? Snap to the middle, and make it somewhat bigger. Now, smart dimension it to be 6.5 millimeters in diameter. Everybody have a black circle? Okay. Who? Okay. Where are you?
The center of
Not letting me snap to the center.
Yeah, so sometimes the snap to things are really finicky, especially with the level of zoom. If you're too zoomed out or too zoomed in, or even if you're too slow, like if you were to just drag your mouse really slowly, it won't do it. So if it's not working, try changing your zoom, doing it a little faster. It's unfortunately it's an art, not a science with the snap to. Is it snapping to?
You can click on the circle maybe.
Okay, well let me show you a trick.
Okay.
Okay, everybody watch my screen for a sec. Say Solidworks is just being a bitch, and it will not snap to, and I make my circle here. See how that's off center? I can force it to snap to. I press this circle, control this circle, hit concentric, boom. Okay, now smart dimension that to 6.5 millimeters. Purple pencil. And now I want you to do a new, instead of blind, do offset from surface, and select this surface right here. And then do 4 millimeters. Everybody see how it's going to cut from that plane into the gear, but there's going to be an offset? Okay, and go ahead and click the green check mark and save. So everybody should have something like that. Does anyone know what that hole is that we just made?
For the head of the screen.
For the head of the screw.
Starting off again.
Okay. Solidworks is quite ornery.
And so
That looks good. Uh-huh. Yep. Okay, so what happens? Do you have a good sketch?
yeah.
Okay, so select the sketch. And now go up here into the features tab.
Oh.
And now hit cut. You're good. Again, if for some reason it looks like your cut exists, god damn it. Watch this.
This surface.
Yeah, exactly.
Oh, how many millimeters?
It's 4. Okay. So now select the other plane. Does everyone have that hole? Okay. Select the other plane. We're going to do a similar hole on the opposite side. Select that plane, extrude cut, do the normal button so that we're looking at it like this.
When I press the plane, it shows the dimension.
That's fine.
Okay.
Okay. Now say that your gear looked like this. Do you want to sketch on this side? No. So press the normal button if that is the case. Okay. Take a circle, auto-align it with the center, and make it about this big. But we want it to be construction. So turn it into a construction circle for me. Everybody remember how to do that? A little check mark in the bottom left. Now the next thing's hard, so I don't want you to do it yet. I want you to just watch me. We're going to make a hexagonal hole. There are many ways to screw this up. So we're going to go slow. So you're going to take a line, zoom in. We're going to start about here at a 45-degree angle and let Solidworks horizontal over to the circle again. Snap to the circle horizontal. Then you come down here and snap to, see how there are 4 circles, or 4 points along the circle? Go ahead and snap there, and then we're going to walk around the circle horizontal to that vertex here. Now, this is not a hexagonal hole. It looks like ass. That's fine. The next thing I do is holding down the control key, I select each of these lines, and in the bottom left I hit the equal button. Okay? Now it's a hexagonal hole. So everybody do that. And would you like me to do that again? I'll give you a try. Does everybody have something that looks like a well-dimensioned hex? Well, not dimensioned, but as in it's proportioned. When you've done that, smart dimension, and click 2 opposite sides like this, and make it 5.5 millimeters. Now,
Can you do one more time how you made all this
Uh-huh.
equal?
okay, so holding down the control, click every single line in a row. See how they're all blue? And now in the lower left hand, press the equal button. It might squawk about unsolvable, just ignore it. The only time when it really is unsolvable is when your whole sketch turns bright yellow or red. Now smart dimension, 2 opposite sides, 5.5 millimeters.
The size of the hexagon?
Yeah. And it should turn black. Okay, go ahead and press the purple pencil thingy. And we're going to do the same thing as last time. Offset from surface. And select the nearest surface, this one right here. And it's going to be 4 millimeters.
From the, like, kind of the same surface on the opposite side.
Yeah, exactly.
So rotate that and then zoom that. There you go.
Is it possible to select a face through the surface?
Through the way, through the one side.
I can't turn. But
I'm sorry, what?
is it possible to select the surface through the body of the
Yeah.
item?
Mm-hmm.
Okay.
Yeah.
How did you, just a general question, come up with these dimensions in terms of like what works with the material you're building this from? And
Oh,
what it doesn't
but
break?
the hex nut I have is 5.5.
I mean, I'm thinking generally in the sort of thickness of the material.
Oh.
You just need to clamp it on, just trial and error and see what kind of.
This
mold.
is roughly the size of clamps you'll buy.
Okay.
You know, a good rule of thumb is if you have a clamp from a company, but you don't have it with a gear on it, you just copy the dimensions of the company's clamp onto the gear and make it bigger if it's plastic. Okay, does everybody have a hex hole? What's that?
I just can't select the surface. I don't have a mouse, so I'm just gonna add. I was gonna make sure I was
Perfect. So if you ever adjust that gap, you'll be screwed, but that's fine.
okay.
Okay, does everybody have a hex hole? Okay. So the next thing is kind of fun. Let's go ahead and hide those planes so we don't have to look at them. And go ahead and save. And now the next thing is called a fillet. Does everyone remember? Well, I'll show you both. Up here, Solidworks, insert, features, chamfer. Remember the chamfer from lecture? Go ahead and select this right here, this edge, and do 0.5 millimeters. And if you can't see it, turn on full preview. Down here, this little button. Everybody's screen should look like this. 0.5. So remember, the chamfer just cuts off the sharp edge. So here's the thing. If this were machined out of like a metal and you were sending this to a shop, you'll want to use a chamfer because they have special tools for chamfering, so it's super easy and cheap. We're 3D printing this one. And the 3D printer does better with smooth edges versus sharp. So instead of doing a chamfer, we're going to do a round. Go ahead and click the check mark just so you see what it looks like. See it? Okay. Now just go ahead and delete that chamfer. I just wanted to show you that's how you do chamfer. Go back and do SolidWorks, Insert, Features, Fillet/Round. Select the exact same edge and do 0.5 millimeters. Anyone tell me the difference? It's round. It's curved. So go ahead and everybody have that edge? So you don't have to only select edges. You can also select faces, but it's very tricky because sometimes it will select sort of weird faces. We're going to do one last edge and then I'll show you a face. Everybody see right here? This edge right here in between this surface and the sort of curved surface with the gear teeth, that edge right there, when I click, this is what it looks like when I add a fillet. Can anyone tell me why in a 3D printed material I would want to put that fillet?
So it's not as sharp.
What happens if it's a sharp?
It'll have a tough time making the layers on top of each other.
It's called a stress concentration. Anytime you have sharp edges internal to a part, it wants to rip apart right there. So by rounding it, we're making it a lot stronger. So go ahead and select that edge. And now see this back face? Select that face. And see how it selects all edges along the perimeter? So that's helpful because it lets us select a lot of edges at once without clicking everything. And now I want you to select this face right here.
Sorry, how did you get all the edges?
Just select the face. Just click. When you click it, select all the edges. And select this internal one here.
So,
How many things are there?
Huh?
How many faces are there?
I want you to do this, all of the internal ones. So this one, and this one, and this one, and this one. So just to show you, this face, all of the internal faces that we made. We're just going to round all of those out so that the printer has a happy time.
0.5.
Yeah, 0.5. Everybody good? As long as you have one round on an edge and one round on a face, I'm happy. Just from a you get the idea perspective. Does everybody have at least one edge and one face? Okay, the last step for this part, select this face and cut. So we need some way of differentiating all of these parts from each other when they're 3D printed. So we're going to put our initials in it. See the giant A here? That's for text. Press the A, type in your initials. And then if you click a different point on the screen, it'll move the text around. But the text is too big for the gear, right? The default text is usually pretty crappy. This little button down here, uncheck that. And check font, and now we're able to make it smaller. So let's do like 0.075. There you go. And I want you to put it roughly center about here. Doesn't have to be precise.
Type of cut.
Just a regular extrude cut.
What was your point dimensions again? It was
units? 0.075.
Oh, inches?
Yeah. And then once you've got your letters looking somewhat like mine, albeit with your own initials. Okay, and now press the green check mark. And make it about 0.5 millimeters deep. That is a completed gear for Lab 1. Does everyone have your letters? Okay, so let me just explain what this does real quick. So this axis is the direction we're going to stuff a shaft through. The reason you see this little thingy here, see how it kind of sweeps over? That's a clamp. So we're going to put a nut here, and we're going to put a screw here, and then when we tighten it on the shaft, the gear won't move with respect to the shaft. We could do a set screw instead. Anybody know what a set screw is?
Or you just screw it in so it's actually touching the shaft.
Yeah, if we had the screw touch the shaft, it would mar the shaft. So then we'd have to put it flat, and that's a pain. So here's the thing. We're a half an hour early from where we were last night. If you'd like, I can go ahead and teach you the next step. Is that helpful? Not? Okay. Everybody open up an internet browser. Go to McMaster.com. McMaster sells a lot of really cool mechanical widgets. It doesn't do specialty stuff typically, but for screws and bearings and stuff, it's terrific. Okay, go ahead and type in screw. God damn it. Socket cap screw. You know what? This is going to take forever. I'm just going to give you a part number to type in. Okay, in the top left, type in 91290A117. Okay, so does this pop up here for you? Press on the button CAD, select 3D Solidworks, Right here. Everybody see the CAD button? Select that, select 3D SolidWorks, and save that to the same folder. I don't. Oh man, this is annoying. I don't think I didn't give you guys any screws in the starter CAD. Stop it! Stop it! Ah, no. Okay, so put that screw in there. Now go back into SolidWorks and open that screw file. Tell me when everybody's got that screw open. Okay, so here's the deal. You can either download this or you can make it from scratch. Which would you rather do? I don't know how many I have. I probably have 300 different types of screws in my latest robot. That's a lot of screws to have to make. If you can, download from the manufacturer's website so you don't have to do it. Now you might say, well, why don't I just make two cylinders, one for the screw head and one for the body? Because not all screws are fully threaded. Some of them, particularly long, will only be threaded for the last 8 millimeters or so, and the rest is solid. And you need to be able to know how far to have threads in the plate that screws into. And I have had this be an error repeatedly at the machine shop where they screwed up, or I screwed up, and I had the wrong number of threads in my hole for the wrong number of threads in my screw. This class, I want photorealism. You should be able to take a snapshot of your CAD and it looks like your robot. That's the only way robots work. I've had so many errors of I didn't include a screw in my CAD and the screw head, when I assembled it, knocked into something else. Not cool. So we have to put screws in, download them from McMaster. Okay, go ahead, File, New, Assembly. Okay, what's an assembly? Putting parts together. Okay. Go ahead and double, so you see how it says begin assembly? Hit the X on that. So we just have a blank assembly. See this button, insert components? Press that. Now it asks us which parts we want to insert. See this that says open documents. Say I have 10,000 parts to choose from, but only 3 are open. It will look just the same here. If you can't find a part, that means it's not open. Go to Browse. Now we can do all of our parts. So I want you to select the CS235 bevel gear we just made, drag it into the middle of your screen, and click. Everybody got a gear in there? Go ahead and save that assembly as, I don't know, CS235 test assim. And if it asks you to save everything, say yes. Everyone got a saved assembly with a gear in it?
SolidWorks crashed.
Awesome! Right as you're trying to save too. I've had that happen a lot. Okay, so try to drag your part. Doesn't move. It barfs. The selected component is fixed. It cannot be moved. Remember that fixed button I said? And how it was terrible? SolidWorks does this by default. The first part you put in an assembly, it always fixes. It does not always fix it properly. It does not always align it properly. Right click, you see this button float? Hit float. Now drag it around, and it drags around just fine. Never, ever, ever, ever let the default be fixed in an assembly in SolidWorks. It will bite you.
Where was the float button?
If you right click on the part, instead of fix, you'll see float. Okay. Now what we're going to do is we're going to line the planes of our part with the planes of the assembly, because that's the clean way to do it. So select. You see how now we have planes for our part and we have planes for our assembly. We have two sets of planes. If I zoom out, these are the assembly planes. Here, if I collapse this, this is my part. These are my assembly planes. And everyone see how, say, top and top aren't aligned? That's bad, so we're going to align them. So select both top planes. And you see this paper clip here? Mate. A mate is a spatial relationship between two things. When you click that button, see how it says top plane of the part, top plane of the assembly, coincident? And your part will probably move. Hit the green check mark. So you know how we just selected two planes and then hit the mate button? That's one way. The other way is now that we're in this window mate, you see this little plus sign here? If I press that plus sign, it shows me everything. Once in the mate window, I can choose other things. So I'm going to choose front plane, green check mark. Now I'm going to choose right plane. Don't press the green check mark. This is coincident. I could do all types of things. I could do perpendicular. Actually, not for this. I could do parallel to make it parallel, but at whatever distance. I could do coincident. I can also see this button here, distance. I could specify I want it to be 50 millimeters away. If I want it to be on the opposite side, I can flip the dimension. I could make it 4 millimeters and flip the dimension. Instead, I just want coincident, okay? Now, we've constrained all three planes. Grab your part and try to drag it. Shouldn't drag. It should say it's fully defined. Is everybody's gear fully defined? Cool. So now that we have, this is the first part, it's not fixed, but it is fully defined, we can add something else. So, insert component, grab that screw, and put it here. Does everybody have a screw? You see these sketches right here? Does everybody's screw have sketches? I don't know why, but for some reason whenever you download McMaster parts, especially screws, it shows the sketches by default. It's really annoying. Go ahead and click on that sketch, not the part, but just the sketch, and just do the hide button on everywhere you see that, because could be less confusing. So now you should have the screw without any sketches visible. It doesn't delete them, it just hides them.
Can you select the whole sketch together, because I'm able to select every edge of the...
You should maybe rotate your view. Click on it. There you go.
Selecting.
So we're good?
Should be saving this assembly as we go.
Yeah. Every time you do anything,
Just try one.
save. Jesse?
So it's selecting each one.
Yeah, that's fine. So if I just select one line
And then right click.
and then hide, the whole thing goes away.
Okay.
So I select that, hide, and it goes away. So there's one last little one down there that you should select. Okay, everybody got a screw with no annoying little sketches in it? Okay, I want you to select this surface, the screw head, and select this whole surface here with the control key. See how both surfaces are blue? That means I've selected them. Hit the paper clip button. Alternatively, you could do Solidworks, insert, mate. See how it moves the screw to be coincident or concentric? The other thing I could do is tangent. We're not going to do that. Just do concentric and hit the check mark. Now select this bottom face here. Rotate the model so that you can access the bottom of the screw head and select that. And it will move. It will automatically think, hey, it looks like it wants to be coincident, and hit the green check mark.
How do you flip the screw around if it tried to go in the wrong way?
Okay, excellent question. Give me one sec.
You could do distance maybe to start. You could do distance 0 and then you can flip it if it's
Here, let me show you. So select this, insert mate. You're probably seeing something like this.
Yeah.
This, mate alignment. It's the same thing as the flipping planes and all that. Okay?
If I did it, okay, so I kept it concentric where it was, and then on the next step, when I tried to touch the surfaces, I get an error saying that concentric won. So I should go back and just do it on the concentric and not on the second step.
Yeah.
It's a step after that.
Select this, and then select this.
Okay.
And then once you've got that, save.
Does that make coincidence?
Yeah.
Wait, how do you say you flip it around?
done.
Oh, okay, right.
Bottom.
Does everybody have the screw in the right place? Okay, grab the screw head and just kind of rotate about its axis. Does it look like your screw is moving? So this is pretty cool. SolidWorks allows us to have things that are physically correct. This is how a screw should work. Once the nut's on here, we should be able to tighten the screw. Okay, everybody go back to McMaster. Type in 90710A030. Yeah. Okay, click the CAD button, 3D SolidWorks, save it. Put that in your folder. Go back into SolidWorks. Open that file. Anybody know what this is?
No.
Yep. Anybody know what type of nut this is? Yep. Anybody know what type of hex nut it is? No, it's a jam nut. A jam nut is a term for like a super, super thin nut. And in 3D printing, you don't want to be tapping into plastic because it'll just rip out. You want to use a nut. Okay, everybody have a nut open? Go back in. Okay, so this is how you switch between parts and assemblies in SolidWorks. Go to SolidWorks, Window, and select whatever you want. If you don't see it there, Browse Open Documents shows you everything that's open. You'll be doing this every 2 seconds once we're doing an assembly. See that? Now everyone should be back here. Everybody back in their assembly? Insert component, insert the nut. Go ahead and save. If it says rebuild the save document, hit yes. Basically, it's called rebuilding when SolidWorks, refreshes with all of the latest changes. If it asks you, just say yes. All right. Say you're here and you want to modify that nut, but you don't feel like going through the trouble of going window and finding it, because if you have like 50 parts open, it's a major pain in the ass. Just right-click that nut and press open part. It doesn't reload it. It just takes you, if it's already open, it'll just take you there. Now here's the thing. We don't have any way of making a concentric thing here. There's no circular surface, so we're going to make ourselves an axis. Press the right plane and the front plane. SolidWorks. Insert, reference geometry, axis. You'll see an axis pop up and hit the green check mark. Right plane and front plane. And it should make sense spatially, because you see how the intersection of those two particular planes gives us the screw axis? Does everybody have an axis? Okay. go ahead, window, and go to your sim. Yes, the models have changed, rebuild, save all. Okay, so hit the nut. Say you want to, I want to modify a plane in this part. The planes are in here, but I don't want to, I've got 1,000 parts and I don't want to scroll through them. Whenever you click on a part in the window, it highlights it in the list. Don't scroll through the list for hours looking. Find the part in the window, or find the part in front of you in 3 dimensions, click it, and it goes to the right place. Expand the plus sign and select the axis, okay? Axis of the nut. Holding down the control button, select the screw head, like this. So everybody should have an axis and a screw head selected. Now insert mate. And now there's something wrong here. Does this look correct? Solidworks for some reason does this obnoxious thing where it could either be coincident or concentric. Coincident means the axis is somewhere along that surface. Concentric is what you want. So press concentric and click the green check mark. Okay, now press, nope.
What if it's going on the other end of the screw?
That's okay. We're going to take care of that.
What if it's kind of in the middle of them?
Totally fine. Okay, take that nut and drag it around. Until we've constrained something about a direction, we are free to move it. Now the one note I will give you is you can't have anything selected when you're doing that. So look on my screen for a sec. If anything appears here, you can't drag things around safely. This is the most common mistake in SolidWorks assemblies. If you press the wrong things for the wrong type of mate where it doesn't make physical sense, it will chug on it for 15 minutes and die. And this happens to me on a weekly basis. It's super annoying. Be really careful what you press here. You don't want to select things that can't be tangent and press tangent. It'll kill the program. So press this surface here and any one of the surfaces on the hex hole. Okay, can anyone tell me if it's a good idea to do a coincident here, or should I do a parallel? Do you know why?
So that you aren't flush.
They might not be the same size. In this case, we happen to have made them the same size. 3D printing material has tolerances. So when I send the file to the 3D printer, it needs to have the proper tolerance. So basically, depending on the surface, our 3D printer will add 2 to 4 thousandths on top of what we wanted, which means we have, maybe sometimes if we want to press fit, we have to adjust it so it's not perfect. So this hex hole might have to be a little bigger or might have to be a little smaller. If we do coincident, it won't work if they're not exactly on top of each other. If we press parallel, they'll be parallel like we want, but it won't be mathematically over-constrained. So press the green check mark, and now drag it around. You see there's only one dimension that hasn't been constrained. Let's constrain that last one. Looking at my screen, check the bottom of the hex hole, and the bottom of the nut, and press the green check mark. Now it is fully constrained. Okay, so now you can see now you can see how this clamp works. We put the shaft through, and now, okay, say we want to see the axis again. We click on the gear, expand the plus sign, scroll down to that axis. So you can, in Assemblies, depending on how yours is set up, you can view different things. So let's do, God damn it. See here under View, you can select what's seeable and what's not. If you select axes, it pops up. And now I can select whichever axis I want, and I can either hide it or I can show it. So go ahead and save that. This is usable as this is one of the assemblies in your homework. So go ahead and open this gear again. Say you have part of the gear that you don't like and you want to get rid of it. Let's select your initials. You're tired of it. You don't want to delete it because maybe you'll put it back later, but you just want it to go away. You don't want to hide it because it's still there, but you just want it to go away. See this button here? Suppress. Click that. It goes away. It's still there, it's just grayed out. We didn't delete it. Now click it again and unsuppress. Suppress is almost as dangerous as fix, but not quite. You do need suppress sometimes, but it's tricky. Let me show you why. Watch my screen. I'm going to suppress fillet. No, that didn't work. Okay. I'm going to suppress up here in the middle, okay? You see all the other crap that got grayed out? It's a parent-child relationship. I had things defined on other things defined on other things. Now watch. I'm going to unsuppress it. It didn't unsuppress these two. What happens if you suppress a parent? It suppresses all the children. Then when you unsuppress the parent, it leaves the children suppressed. If you have something with 100 features, you're going to be clicking for a long time. So just go ahead and Control Z until you're back to normal. Or if it's totally screwed, just close the document because the last saved version is fine. Okay, it's 3:54. You all have done remarkably well. And that is the hardest part / assembly of the entire homework. So homework 1 consists of making a few parts, planar parts from scratch, making this gear assembly, making several other assemblies, and putting them all together into one master assembly. Just to show you real quick, I could do new assembly, and I don't have to just put in parts. I can put in assemblies. Here's an assembly. Here's another assembly. Okay? So I can have these are called sub-assemblies. So this is what your homework is going to be like. You're going to have one master assembly that contains other sub-assemblies and parts. Now it's the same thing with computer programming. You need to structure it intelligently. You don't want to have one assembly and all parts. Anyone know why? You're going to be clicking an awful lot unnecessarily. Say we have 50 of these gears. We can either make one assembly and insert it 50 times, or we can make this assembly 50 separate times, and then every time we say, oh, I didn't want a 12 millimeter screw, I wanted a 14 millimeter screw, we're screwed. So you want to make intelligent choices in terms of, if it's a one of a kind, it's fine, just throw the parts into the master assembly. If you're ever copying it, make a sub-assembly. It'll save you a lot of time and effort. Any questions? Yep.
What about the threads and the screws? Is that a problem when you're doing collision analysis? Because right now you can't be sure if you're actually...
So we're not going to be doing collision analysis.
Yeah.
That's one of those more advanced features. It's a little buggy, I think. I just do a visual inspection. I've used it a couple times, but I don't think it's an appropriate usage to be looking at, is the screw colliding with the nut. That'll
But
get.
it might interfere with other analysis.
We're not.
Most of the CD programs don't depict the screws, the threads.
Yeah.
For that reason, right?
We're not going to be doing any analyses in this class, and I would encourage you all not to do any analyses either. It's one of those things where, so I worked at Lockheed Martin, and they were designing this evil thing where it's basically a pod of missiles, and you go to a country you might want to bomb in the future, and you shove it off the end, and it just sinks into their coastline, and then once they get someone we'd like to take out, we activate it, these little arms go down and it starts launching missiles, and they did this really complicated hydrodynamic analysis showing that it will work perfectly. And what happened is it's beneath the water surface, and it comes down and plants these little flower petals, and it's supposed to shoot straight up, and the movie goes, and the entire thing shifts right, goes sideways, and the missile goes, And they were like, oh, holy shit, what happened? We analyzed this for months. Analysis is not the real world. The problem, most of analysis guys' time is spent saying, why don't my experiments match my analysis? Oh, I'm sorry, that's right. My starting assumptions or boundary conditions for my analysis didn't work. So for me, it takes a lot less time to just do the analysis myself. It's the same thing with finite elements. If I have a beam and I put a weight, there's no reason to do that in SolidWorks. I can look up on Wikipedia in 2 seconds the stress and bending equations for cantilevered beam. They're very easy, and I can get it done in 2 seconds without doing anything in SolidWorks and be guaranteed I'm correct. So for this class, we're not doing any analyses, and I would strongly urge you to only use SolidWorks for the bare minimum you need it for in terms of functionality, which is making parts, making assemblies. The most advanced thing you'll be doing in terms of analysis is setting mass properties. So I can just show you that real quick. If I open this gear and I go to Tools, oh, 2 more things, sorry. This is very important. Tools, Measure. You'll use this all the time. Click on this diameter, and it tells you the diameter. Click on this face, and this face, it tells you the distance between the two. If you think your part is done, please don't send it to me until you've gone through and measured things to say, hey, this is 4 millimeters. Hey, this is 8.1 millimeters. This is 25 millimeters. Does everyone see how to do this? This is probably the most common tool in all of SolidWorks that I use. Because sometimes you'll forget to actually accept changes and it won't take, or sometimes just something won't work. This is ground truth for us. If this says 0.26 inches, it is 0.26 inches. The last thing is I can go Tools, Mass Properties, Options, and then use Custom Settings, and I can set a mass. In this case, I believe it's 118. So this part, when I print it, will be 8.54 grams. It's precise enough that if I 3D print this, it will be 8.54 grams. And why this is useful is later on, there are 2 reasons. It will tell you whether or not you need a forklift for your robot. That's funny, but my robot, it's a 15-degree freedom medical robot. It's meant to be in a hospital. I actually had to get a special order pallet jack just for installing it in places. The other thing is if you have counterbalances that are based on gravity and gravity bobs, this is how you determine how big that gravity bob is and where it goes. I use it, but that's the most advanced thing I do, and it makes me super nervous. There are things where, like, I'll have something and it'll tell me it's 5 pounds. I'm like, there's no way that's 5 pounds. So, if it happens, it tells you it's 5 pounds, and you don't believe it, what do? You weigh it. If you ever have a question about a dimension or a mass in SolidWorks, you go and you take your calipers and you measure it. You get a scale and you measure it. Only when your experiment matches your model are you done. If there is any difference between the two, someone screwed up somewhere and your robot will not work. Okay, that's it. Unless you guys have extra questions. I'm going to post this to YouTube. And then we got further today than we did yesterday. But still, I'm going to be going over only assemblies and then also drawings. There's one more SolidWorks file type drawings next week, sometime at night. And I'm going to draw you one quick curve. So,
are you going to post the homework? Is that?
Yeah, I'll probably post it over the weekend, but I haven't told you all about the different gear types in lecture yet, so it won't make much sense for you to start it. Mm-hmm. And I'll push back the deadline so that everyone has reasonable time. This is effort for the course. This is time. Here we are now. This is June. Okay, so here's the thing. This section here, this is week 2. This section here of high effort is PRL safety training, Clark safety training, SolidWorks training. This is the annoying stuff that we have to do so that we can do this section, which is the labs, which Once you know how to use SolidWorks and how to use our tools, it will go really fast. And then this is the, oh shit, we have a final project section. It's a project class. This is standard. Please don't feel freaked out and overwhelmed by the number of emails I'm sending and how difficult SolidWorks is. I know it's hard. It's okay. You actually did really well. I'm very pleased. I can't believe we got all the way through a full assembly. Make it through the first 2 weeks, and I promise you it will get much easier. I'm not planning on having any special lectures at night or on the weekends until basically the final project after next week. Next week we're going to have several special lectures for SolidWorks, and also we have a parts manufacturer who's going to teach you how to buy stuff for your robot. And then that's it. After next week, I'm not going to ask you to come in for special outside of class lectures on nights or weekends. Just get through next week and you'll be home free.
What was the density?
I think it was 0.00118.
Posting the class lectures on YouTube?
Yes, so I've been a little too busy recently, but over the weekend I'm going to post every single video I've taken.
And another question I just noticed today, I had the Solidworks on my laptop, but the version I had, the key ran out, so if I could borrow a copy from you to